Hi friends, greetings to all. My name is Mr. M. Raja. I am working as a assistant professor in the Department of Food Technology. I am working in Excel Engineering College, which is located in Namakkal district. Uh, Today we are going to discuss about chromatographic techniques related to the food technology applications. So first, before entering to the topic, first we have to know that what is the necessity of doing the food analysis. Okay, so here we know that the necessity of the food analysis, we have first we have to identify the characteristics of the food properties of the food product, and to mainly here they will check the physical properties, chemical properties, and the physiochemical properties of the food product, sensory attributes, and structural composition parameters of the food products. We have to analyze molecules which is present in the food product, we have to analyze. At the same time, to meet out the legal requirements and labeling requirements, we must carry out the food analysis. It is mandatory as to sell our product in the market. At the same time, to assess the quality of the food product, it is necessary to perform the food analysis. Excuse me. See here, also for the sensory attributes. So these are all the main important to carry out the food analysis. So uh, here we will discuss about the chromatographic techniques. So before entering into the chromatographic techniques, first we will discuss about chromatography. The term chromatography coined by the scientist called Mikhail Tves. He first analytical use of chromatography was described by James and Martin in the year of 1952 for use of gas chromatography for the analysis of fatty acid mixes. A wide range of chromatographic procedures makes use a difference in sizes, binding affinities, charge, and other properties to separate the materials present in the food products. It is a powerful separation tool that is used in all branches of science and is often the only means of separating the components from the complex mixes. Excuse me. So here, generally for the food product, they are having numerous techniques to analyze the food products. So here, first they will prefer the chromatographic techniques, spectroscopic techniques, and hyphenated techniques, thermal analysis method. And among the four different methods, the chromatographic techniques it will provide the high accurate result. So most of the food industry prefer the chromatographic techniques, and the results are highly accurate, and it is a time consuming process. But nowadays, because of the advancements, that the amount of samples required for analysis also very less, and it will give the time consumption also reduce year over year. So here, the chromatography is based on the principle where the molecular mixture is present in the food product applied onto the surface of the solid material, and fluid phase and stationary phase. It will be called as a stable phase, or sometimes it will be called a stationary phase, separating from each other while moving the mobile phase. With the help of mobile phase, the molecules present in the food sample, it will be separated. Okay, some of the food sample molecules present in the food sample, it will be adhered to the stationary phase itself. So it is depends on the polarity and the interaction between the molecules present in the food sample and the stationary phase. So mostly, so depends on the polarity and depends on the size of the particle. The molecules can be easily separated with the help of stationary phase, mobile phase, at the same time the medium also. So here the factors effective on the separation process include molecular characteristics related to the adsorption, liquid-solid interaction, so partition, liquid-solid partition, and the affinity or differences among their molecular weights, as we discussed in the earlier. So here it is separated based on the molecular weight, at the same time based on the polarity also. So because of these differences, some components of the mixes stay longer in the stationary phase, and they move slowly in the chromatographic system, while the other rapidly move faster along with the mobile phase and leaves from the systems. So here generally the three components plays very important role in the chromatography techniques: the stationary phase, mobile phase, and the separated molecule. The stationary phase, this is a phase, is all phase composed of a solid material or a layer of a liquid adsorbed on the solid support material. So it will be interact with the molecules which is present in the food product. And the next one is a mobile phase. This phase is always composed of liquid or a gaseous component. So it is helpful for separating the molecules present in the given sample with the help of molecular weight as well as the polarity. Next one is a separated molecule. The type of interaction between a stationary phase, mobile phase, and a substance contained in the mixture is a basic component effective on the separation of molecules from each other. So here these three components are very important, and we have to choose it very carefully whether we need solid support medium or liquid adsorbed on the solid support medium as a stationary phase, or a mobile phase we have to go for liquid phase or a gaseous phase. Depends on our requirement and depends on the category of the sample analysis. We have to go for we have to select carefully a stationary phase as well as the mobile phase, and it will give the better result and accurate result also. So this is the general pictorial representation of a thin layer chromatography or paper chromatography. So here in the early stages, they extracted the molecules from the plant materials. The plant is harvested and it is ground into small molecules, and it is mixed along with the solvent, and the solvent is the plant material is dissolved along with the solvent material, and the solvent is transferred to the beaker. So here we have if you check the beaker, the beaker is having a thin paper. We have this excuse me, this here we are using acetone or a propane as a solvent material, and here we have a leaf extract. So we have marked at the bottom. In the bottom we have taken the small amount of the sample and it is placed in the marked line, and due to the capillary actions, the acetone or the solvent material which is present in the beaker, it will flow from the bottom of the paper to the top of the paper. It is depends due to the capillary actions. The molecules present in the spotted area which is used for the leaf extract. Here we have a n number of molecules as represented in the third part of the diagram. That is the right hand side of the diagram. All molecules are separated, depends on the molecular weight and the polarity. See, if you check it, the anthocyanin, it is present along in the bottom line of the paper chromatography, and the chlorophyll B, chlorophyll A, and carotenoids, xanthophylls, and carotenoids, and the solvent molecules are there. So we have this movement is there, depends on the partition coefficient and the interaction between the mobile phase and the molecules present in the plant extract, and it will move faster or it will move slower. So it is depends on the molecular weight and the polarity. So next, generally we have here different types of the chromatographic techniques. So based on the chromatographic bed, it can be divided into two major category: planar chromatography, column chromatography. The planar chromatography, we have two subcategory, that is paper chromatography, thin layer chromatography. In the column chromatography, it is majorly separated as gas chromatography and liquid chromatography. So apart from this, we have different types of chromatography techniques: column chromatography and affinity chromatography. We have different techniques which comes under the column chromatography. So here this is the major classification of the chromatographic techniques. So now we are going to discuss about the paper chromatography technique. It is one of the basic chromatography techniques used for laboratory to analyze the food products. See here, the paper chromatography is a liquid partition chromatography. So here the mobile phase is liquid medium and stationary phase is a solid medium, okay, solid support material. In paper chromatography, the end of the paper, the bottom of the paper is dipped in the solvent mixture as we shown in the second diagram. The end of the paper is dipped in the solvent mixture, and here constituting the aqueous medium along with the organic component. The solvent soaks in the paper by capillary action because of the fibrous nature of the paper, and the solvent molecule will flow from bottom of the paper to top of the paper. So it will be called as ascending paper chromatography. The aqueous component of the solvent binds to the cellulose paper and thereby forms a stationary phase with it. The organic component of the solvent binds continuous migrate, thus forming a mobile phase. So here the organic molecule will be forming a mobile phase, and the liquid molecule, that means the aqueous component present in the solvent, it will be acting as a stationary phase. So the spotted area will be at the bottom of the layer. Here we have spotted A, B, C, 3 layer. We can view the movement of the molecules from the bottom of the paper chromatography. So here the mechanism of separation. The mobile phases rises up by capillary action. The testing sample is concentrated as a minute spot at the bottom of the filter paper. The sample mixture gradually rises up with the mobile phase. Along with the mobile phase, which is the liquid medium, the compounds in the mixture will be separated according to the solubility. More polar substances will move slower and less polar substances will travel faster, because the affinity between the polar substances and the stationary phase will be very high, so it will move slower. The affinity between the less polar substances and the stationary phases is very less, so it can move faster along with the mobile phase. So this is the basic mechanism of the separation of molecules present in the food product with the help of paper chromatography. So here generally the procedures. So we are taking the small pieces of the paper, most probably the 2 centimeters width of the paper and 5 to 7 centimeter, depends on the requirement. Mostly they will prefer 2 centimeter width and 7 centimeter height of the paper. The length of the paper will be 7 centimeter, and from the bottom they will leave 1.5 to 2 centimeter. They will draw the bottom line. It will be called as a base of the plate. Okay. So here this sample is absorbed onto the paper, and it will allow to the interact with the solvent which is present in the beaker. Okay. So the paper is then dipped into the solvent such as ethanol, or that means mostly we have organic plus aqueous component present in the solvent medium. So here we have to take care carefully. The bottom line should not touch the solvent medium directly. Okay. So it will be interact with the paper layer, then it will reach the base layer, then the spotted portion which is present in the bottom layer, that is bottom line, and it will be here we are spotting the 2 to 3 drops. Okay, 2 to 3 extract material, and it will interact, then it will so here it will be acting as a stationary phase under the mobile phase, and the aqueous component will be acting as a stationary phase, and the organic component will be acting as a mobile phase. And here if the substance spotted substance having higher amount of the polar material, this polar material interact with the aqueous component, and it will retain in the bottom layer, and it will move very slowly, and the non-polar substance, it will move along with the organic molecule, that is organic substance present in the solvent medium. It will be acting as a mobile phase, and it will move faster. So depends on the rate of flow and the distance which is traveled, we could able to identify the different types of we can able to separate the molecules present in the food product. So similarly here if you check it, in the bottom we have a solvent medium, and the thin paper is which is dipped into the solvent medium, and we have drawn a bottom line, and we have spotted three spots on the bottom line. One is a red color, another one is a blue color, another one is third one is a green color, which is not directly interacting with the solvent which is present in the beaker. So it will move faster, and if the spotted portion having higher amount of non-polar substance, if spotted portion having a higher amount of polar substance, it will move slower. So this is the general mechanism of paper chromatography. So here the solvent moves up the paper by capillary reactions and dissolve the sample mixture, which will then travel up the paper the solvent solute sample. So different compounds in the sample mixture travel at different rates, depends on the polarity and the solubility and affinity between the stationary phase and the organic phase, that is mobile phase. It takes several minutes to several hours, depends on the molecular weight. So here analysis, the spots corresponds to the different component may be located by their color, UV light or spraying of ninhydrin or by the treatment with the iodine vapors. So depends on that we could be able to identify and recognize the different types of molecules present in the spots. So here the paper chromatography, again it is divided into two categories, ascending and descending paper chromatography. The ascending, in this method the solvent is present in the pool. The solvent is in the pool at the bottom of the vessel in which paper is supported. Okay, so here if you check it, the solvent is in the bottom of the vessel and the paper is supported. So here check it, in this solvent is at the bottom of the chamber and paper is supported with the clip. Okay, so here it is called as the solvent will flow from bottom of the paper to the top of the paper. So it will be called as ascending paper chromatography. So here it rises up the paper by capillary reaction against the force of gravity. So against the force of gravity, so it will be called as ascending chromatography. Next one is a descending chromatography. In this method the solvent is kept in a trough at the top of the chamber and it is allowed to flow down the paper. This liquid moves down by capillary action as well as by the gravitational force. So most of the industries they will prefer ascending chromatography. It is one of the easiest technique to carry out the food analysis for the food product. Next one is a significance of the paper chromatography. It is very easy and simple, rapid and highly efficient method for separation, can be applied in micrograms quantities of the sample, can also be used for the separation of wide variety of material like amino acid, oligosaccharides and glycosides, purines and pyridamines, steroids, vitamins and alkaloids like penicillins, tetracyclines and streptomycins. So these are all the general significance of the paper chromatography, and mostly they will prefer the paper chromatography for the laboratory applications. Okay, but for the R&D purpose, nowadays recent days most of the food industry prefers the advanced equipments like thin layer chromatography, gas chromatography, HPLC and high pressure liquid chromatography along with the mass spectroscopy. They are preferring for the better understanding to identify the quality of the food, assess the quality of the food product and identify any adulterants present in the food product. So it is to meet out the requirements of the lab legal compliance of the food products. And apart from that, the chromatographic techniques mostly used for different sectors of the industries, especially for the pharmaceutical industries, biotechnological applications, especially in the biotechnological application, molecular biological applications. They are preferring the chromatography techniques, and the chemical industries, food industries, forensic science also they are preferring the chromatographic techniques. I hope that these slides, this presentation will give the basic understanding of the chromatographic techniques related to the food industries applications.